Hello guys and welcome back to my channel. This is Trusty Rusty Depot and today we're going over structs in Rust and what they're useful for. So let's dive right into it. So I opened up my terminal here and I'm going to create a new project and I'm going to call it structs. And then I'm going to go into that project and let's go inside the source folder and main.rs. Let's get rid of the default hello world. So first things first, what is a struct? So a struct is a way of defining a user type that can be used to store data in an organized, named way. So in order to create a struct, we're going to first write the keyword struct, and then we're going to name the struct. I'm going to name this one human. And notice the capitalization of the first letter. Struct names should always be in camel case. That is just the naming convention for structs. So then we're going to put brackets here, curly braces, and we're going to write in here all of the named data called fields that we want. So the format is field and then colon and then the type. So like string, for example. And the fields should all be in snake case, just like function names and variable names in Rust. We're going to name this one name, and it's going to have a type of string. Now structs can have as many fields as you want them to have. We're going to add age, and then we're going to make this a U32, and then we're going to give it a birthday, which I'm going to make a string. So now that we have our struct, so we need to create instances of human, the struct, that will have concrete values stored in it under these names, name, age, and birthday. So if we go inside of this main function and we create a variable called Bob, and we're going to set it equal to human, braces, and then we put name, so we're going to call it Bob. And then we put age, so we're going to say he's 24. And then the birthday, we're going to say that the birthday of Bob is January 22nd of 1999. Now we need to put the semicolon at the end. Now that we've created this instance of named Bob of human, and if you notice, the type here is human, just like the name of the struct, because remember that the struct is a type and it's a way to create a custom type. Now, if we wanted to be able to mutate or change Bob in any way, like if we want to change his name, we could make this mutable, and then right here we could access the name by using the dot convention. So we call the variable the instance of the struct, so Bob, and we say dot, and then we want to access name. So bob.name equals, and we're going to say Bob changes name to Fred. So now we can also go ahead and print Bob's name, so Bob's new name, and then we can print here bob.name, and we access the variable the same way. So instance dot the name of the value. Now, let's say we want to create a second human called Jen, and let's say that it's a human of the name Jen with the age of 24 and the birthday conveniently the same as Bob's birthday. We put a semicolon at the end. Because Jen's age and birthday are exactly the same as Bob's, we really don't want to write age 24, birthday, string from January 22nd, 1999, every time. So instead of that, what we can do is we can use what's called the struct update syntax. So let's get rid of age and birthday. So we put name, and then we put a dot dot, and then we put Bob. And so Rust will fill in the rest of the struct with whatever Bob has in here. So now if we print the new human and we say the age of Jen, gen.age. If we run this, cargo run, we get that the age of Jen is 24. So you can see that the age was updated correctly from Bob's age. Now, there's a couple of different types of structs. This first one is the one that is normally used. There's another type of struct called the tuple-like struct, and it's very similar to a tuple, except that it has a name in front of it. For this type, we just write struct, we give it a name like color, and we put parentheses, and then we fill in the types that we want it to have, just like in a tuple. So let's say we want to have 3 U32s. Now we can use this struct, and we can say let black equals color, and then 0, 0, 0. Now, you can even, if you want to, create a struct without anything inside of it. It's called a unit struct, and we can just define it like this. And the unit struct, we can just say unit equals unit struct. We have a struct with nothing inside of it. Now, to make structs more useful, we can define functions that can be used on the structs, and these are called methods, and they are always associated with a struct, and they can be called on the instances of a struct. So, for example, in order to create some methods for the struct human, we can write the keyword imp, which stands for implement, and then we can put human, the struct, and then curly braces. Now, everything inside of this will be associated with the struct human. So we can create a function, and it will take in a variable called human of the type human, and all it will do is print hello. Now, because we know that this is human, and the type is already written here, we can actually use a keyword called self, and right here we can call it self. And because this is so commonly used, we can actually just replace this whole thing with self. And since we want a reference to self, we can put and self. And that would be the same as writing self and self like this inside of the parentheses. So now that we have this function defined, we can use it up here in our main function. We can call it on Bob, for example. We say Bob dot and the method name greet, and then parentheses. Notice that we don't pass in the self parameter. The self parameter is passed in implicitly because we're calling it on this instance of human. So that first self parameter is always passed by just calling it on that instance of the struct. Now, let's try to make this a bit more useful, and let's try to make it take in another human that this human will greet. So let's say greet human self, and now it'll take in another parameter of type human, and it will print hello and then other.name. So now we can use this one by saying bob.greetHuman, and then we could say Jen in here. Now, sometimes you don't need to take in a parameter of self. You need the function to instead be associated with the struct without needing to be called on an instance of the struct. A very common example of this is the function called new, which usually is defined to create a new instance of the struct. So in order to create that function, we can write function new, and then we can write that it takes in a name of type string, an age of type U32, a birthday of type string. And then the function returns a human. So in order for that to happen, we need to write an instance of human in here. So human, braces, and then we put name, colon name, age, colon age, and then birthday, colon birthday. As you can tell, writing name is a bit tedious every time. So there's actually a shorthand for it because the name of the variable and the name of the field is exactly the same, we can actually just write name here, and we can do the same for all of these. We can say name, age, and birthday, and that is actually much neater than before. So now we can use this to create the new instance of Bob up here. Instead of using this, we can do human, and then colon colon is the syntax, and then we call new, and then the parentheses, and then we pass in the name, which we said was Bob, and then we pass in the age, which is 24, and then the birthday, which was January 22nd, 1999. And now we can do the same thing for Jen. And then we can use the instances the same way as before, because this method returns a new instance of human. Now, if we wanted to, we could take this method and put it inside of a new implement block. This would also be valid syntax, and I'm going to cover a reason for doing this in a later video. Thank you so much for watching this video. I will see you in my next one.